In this chapter, we're going to talk about packages and how you can build your own packages for your own work. We have a bunch of experience using packages. We've been downloading packages from CRAN and using them all throughout the semester. But now we're going to talk about what it actually takes to build a package. And we're going to set it up under two circumstances. The first circumstance is using a package just to encapsulate a data analysis project where you're not trying to share this with the world, but rather you're trying to make it accessible so that you can share it to your co-authors or other people in your lab group or what have you. So we're going to talk about R packages as a way of encapsulating a project. The process of creating a package can be made a lot easier by using a couple of other packages that are sort of infrastructure packages that are designed to try to make building and maintaining a package much easier. In particular, there's a package called dev tools, which one way to describe this is these are tools for Hadley built by Hadley, with the idea that as Hadley has built well over 30 major well-used packages, he's found that there's a bunch of things that he does in the package building and maintenance that sort of are repetitive, and he made the dev tools package to try to address some of those issues. Next, we're going to look at the R Oxygen 2 package, which tries to take documentation that you put at the creation of either your data sets or your functions that discuss how that function should be used, and builds R's internal documentation system using that. So we're going to use R Oxygen to build any of our help files. Next, we're going to talk about test that, which is a way of taking a R function and testing it systematically. One of the big problems with commercial software is that when you start adding new bells and whistles and new features to your software, sometimes it ends up breaking old functionality, and we need a way of testing whether a function that we have written actually does what we think it should do. And test that it handles that sort of testing automatically. This is a fabulous way to do this. And then finally, use this is a nice package that sort of helps me set up the basic structure of a package very quickly and very easily. So these packages are sort of infrastructure packages that help me build my packages more quickly. Now, the last thing is that if you want more detail into our packages, Hadley has written a really good book about what a package should look like, and it's freely available online. And if you go to this page, there's a huge amount of information about individual topics that we're going to briefly cover in this class, but it's discussed in a great deal more detail in Hadley's book. And I own this book and I consult it relatively frequently. So, yeah, I recommend this book. As far as R is concerned, a package is just a folder. Now, the folder has to be organized in a very particular way, but as far as R cares, a package is just the right things placed in the right places. Now, we've got some minimal files that have to be present for this to be a R package. In particular, we've got a file that is the description file, and this thing describes what the package is all about. And this is something that you should edit to describe what the data is for, what the whole purpose of the thing is. And this is something that you should edit by hand. You need to have a directory entitled R. So there's going to be a subdirectory with R, and there are two things that go into this directory. First, you get R files that are scripts that define functions. So anytime you write a function, it should go in a file in this R directory. Second, the documentation for any data set that you have should go in this directory. And we'll talk about what those documentation files look like later, but those are the two things that live in this R directory. And these are really the only two things that you have to make or modify. These other three, this namespace, build ignore, and this man page, these are the manual pages, you don't mess with these guys. So really it's just the R and the description file that you're going to mess with. Now there's a bunch of optional files as well, and we're going to kind of step through these in just a second, but let's first start with the minimal files. Packages can have some optional directories as well. Now the first three of these are directories that I very often have whenever I have a data analysis type project. Sort of the first one to think about is this data-raw directory. And this directory is a place where you should put any of your data sets that are in, say, comma separated values file or Excel files. And what these are data sets that haven't been cleaned up, they haven't been stored in a nice R-centric way to deal with it. And these data sets are sort of the raw data sets that I have. Now, inside this data raw directory, I'll also have a script. And I'll have an R script that reads in the data from that directory, does some sort of data wrangling and cleaning and all of the things that I need to do to get it set up. And then what it'll do is it'll save whatever data that I've now read into the data directory. Now the data directory is the place where you put cleaned up data that's stored in the R-centric R data or RDA. These actually are the same file extension. This is just the Windows version of it where it has to be 3. So it'll be saved in a R-centric format, and then whenever you load the library or the package, these data sets will also be loaded. And so the usual work process is that you'll have the raw data in data raw, you'll do whatever cleaning, you'll load that, you'll save that data to the data directory, and then you'll go ahead and you'll build a report that does your analysis. Now the report that does your analysis should live in this docs directory. And this docs directory is where you can put R markdown files that are especially time consuming, and this is sort of your final output for the project. And so whenever I do a data analysis project, these first three directories pretty much always will show up, in that I'll have a raw data along with some script for cleaning, some stored versions of the cleaned up data that I'll then use inside my R markdown documents that lives in the docs directory. And that is my usual file analysis. Now there's some other directories that can exist but aren't required to, and these sorts of things typically show up in a R package where you're creating some sort of tool or methodology or functions that other people are going to use. The vignettes directory is going to be where our markdown files go that introduce how to use your package. And when you rebuild your package, these R markdown files will also be rebuilt and rerun. So every time that I make a modification and I rebuild my package, these vignettes will get rerun. And so you don't want these things to be super time consuming to build. But typically these are introductory, how do I use the package, as opposed to some sort of formal results. There's another directory called tests, and this is going to be where you put any of your function verification test code that will validate that whatever functions you have, continue to work when you do this. So if we're doing some sort of functions that might need to be tested when I update the package, that's where those tests will go. This INST, this is kind of the installed miscellaneous stuff. Um, so this install extra data, ext data, is where you might put data in Excel files that you want to that your users can have access to. So for example, if I'm doing a package that has some functionality for reading Excel files, then I want to give my users some Excel files that they can actually access. And the install directory is where those should go. Now for a data analysis package, I would never do this. I would put it in data raw, but that's okay. The source directory, if you're dealing with a package that has some compiled C code, it goes in here. And likewise, this is where the source directory for that code is, and the executable directory is where those executables that get created from the source code end up going. So these last 5 are really aimed at programmers and people that are building R packages that are tool-based sorts of things. So for the data analysis group, you're going to have really these extra 3 directories: data raw, data, and the documents directory. The process of creating a package can be made a lot easier by using a couple of other packages that are sort of infrastructure packages that are designed to try to make building and maintaining a package much, much, much easier. In particular, there's a package called DevTools, which one way to describe this is these are tools for Hadley built by Hadley, with the idea that as Hadley has built well over 30 major well-used packages, he's found that there's a bunch of things that he does in the package building and maintenance that sort of are repetitive, and he made the DevTools package to try to address some of those issues. Next, we're going to look at the ROxygen 2 package, which tries to take documentation that you put at the creation of either your data sets or your functions that discuss how that function should be used, and builds R's internal documentation system using that. So we're going to use ROxygen to build any of our help files. Next, we're going to talk about test that, which is a way of taking a R function and testing it systematically. One of the big problems with commercial software is that when you start adding new bells and whistles and new features to your software, sometimes it ends up breaking old functionality, and we need a way of testing whether a function that we've written actually does what we think it should do. And test that it handles that sort of testing automatically. This is a fabulous way to do this. And then finally, use this is a nice package that sort of helps me set up the basic structure of a package very quickly and very easily. So these packages are sort of infrastructure packages that help me build my packages more quickly. Now, the last thing is that if you want more detail into R packages, Hadley has written a really good book about what a package should look like, and it's freely available online. And if you go to this page, there's a huge amount of information about individual topics that we're going to briefly cover in this class, but it's discussed in a great deal more detail in Hadley's book. And I own this book and I consult it relatively frequently. So, yeah, I recommend this book. As far as R is concerned, a package is just a folder. Now, the folder has to be organized in a very particular way, but as far as R cares, a package is just the right things placed in the right places. Now, we've got some minimal files that have to be present for this to be a R package. In particular, we've got a file that is the description file, and this thing describes what the package is all about. And this is something that you should edit to describe what the data is for, what the whole purpose of the thing is. And this is something that you should edit by hand. You need to have a directory entitled R. So there's going to be a subdirectory with R, and there are two things that go into this directory. First, you get R files that are scripts that define functions. So anytime you write a function, it should go in a file in this R directory. Second, the documentation for any data set that you have should go in this directory. And we'll talk about what those documentation files look like later, but those are the two things that live in this R directory. And these are really the only two things that you have to make or modify. These other three, this namespace, build ignore, and this man page, these are the manual pages, you don't mess with these guys. So really it's just the R and the description file that you're going to mess with. Now there's a bunch of optional files as well, and we're going to kind of step through these in just a second, but let's first start with the minimal files. Let's start with figuring out how to start a package within RStudio. So what I'm going to do is I'm going to go up to this file and this new project. Now a project and a package can be very, very similar. The project is RStudio's nomenclature for how it deals with directory structures. So think about a package as a special version of a project. So we're going to go to project, and I'm going to start a new directory, and I'm going to use an R package using DevTools. Now there's a couple of other things in here that are pretty useful. For example, this bookdown and R Markdown website are pretty cool too. But we're going to use this, we're going to create a new R package, and we're going to use Hadley's DevTool package to help build things. So we're going to select on this, and we're going to give this a name. So we're going to call this testing package. And you can put it as a subdirectory of some other directory as well. So I'm going to put it with where I put all of my GitHub stuff. All right, so this is going to create the skeleton of my package. And you can see that DevTools is doing some stuff in the background, and we're going to restart RStudio, and now we're going to start it using inside this package mode. And so up here it says I'm working on this particular project, which is this testing package. Now, the creation of this has built some of the necessary framework. So it's built this R directory where we're going to put our functions and our dataset documentation. It's built this namespace thing, which we'll talk about in a while, and it's also built this description file as well. So it's built all of the base stuff that we need all for us, and now we just need to be able to go in and modify things. Now this description file, there's some interesting information that it's sort of built or pre-populated to begin with. So it gives it the package name, which is sort of what we started with, and we also have this title, and it's pretty clear that I should go in and change this so that I can see make this be a little bit more distinct. It can give you the author, so you'll fill in your first and last name and your contact email. And then this is a longer description of what the package actually does. And there's a few other things that you can do as well inside this file, but this is what gets populated at the beginning. When I'm building a package for a data analysis project, these three directories are often in my package. We're going to start with this data raw directory. Now in this directory, we store our data that comes to us in either a CSV or an Excel file or something like that. And this is where those data are going to live. And also in this directory, there's going to be a script. There's going to be an R script that reads the data in and does some data cleaning and data wrangling and processing and gets it into a usable format that we can use for the entire rest of our analysis. So in that data raw directory, that's sort of where the data comes in first to be processed. Once it's processed, we're going to save that data over in the data directory. So data sets that live here should be in an R-specific format, this RData format that is created using the save command. And anything that lives inside this data directory is going to be loaded automatically when the user loads your package. And so data that lives here should be the final, clean, best version of the data that you've got. Now, once you've got your data, you're going to create an R Markdown file that does whatever analysis you want to do. And that R Markdown file should live in the docs directory. And this is sort of where all the documents and results of the data analysis should actually live. Now, there's a few other directories that could exist and typically exist when you're dealing with a package whose primary purpose is to provide functions and tools that users will then turn around and use. So in the vignettes package, this is where vignettes should go that will be used to introduce people to how you use the tools that are in the package. The tests directory, this is where any sort of quality control testing scripts are going to end up going. And so that's strictly for code that or functions that need to be tested and will be used over and over and over again. So the testing functionality goes in here. This INST, I think this stands for installed. This has some miscellaneous information. For the most part, I don't put anything in there. Source, this is a directory that if you need to have other programming languages involved in your package, this is where the source code for your C, C++, Fortran, Python, this is where those source files will exist. And then once they're compiled into an executable, they'll end up going into that executable directory. So for the most part, whenever I'm doing a data analysis package, really just these first three directories end up getting used. Within our test package, I've added a few of the optional directories, in particular the documents, the data raw, and the data directory. Let's start with the data raw directory. What I've done is I've loaded up a comma-separated values file, which is the Flagstaff maximum temperatures. And you can look at this and see this is just a standard data file. Now, in this same directory is an R script, and this R script can be executed whenever I want, and what it'll do is it'll read in the current directory, it'll read this flag maximum temperature, and it'll do some cleaning, and all of this serves to make this maximum temperature into a format that is really easy to work with and use. And then finally what I'll do is I'll use this maximum temperature and I want to save it in a format that is going to be easy so that whenever I load this package, max temperature is just ready and available. So what we're going to do is we're going to use the package use this, which is a handy thing that Hadley has that allows you to put in the appropriate place this cleaned up data set. So what this is saying is use the cleaned up data set maximum temperature and put it wherever is appropriate. We'll also run this script at the very beginning. After we've written it and figured out what it takes to clean it up, I will run that script. Now, where is appropriate is in the data directory. And so what that use this function has done is it's created this .rda file, which is R's sort of internal representation of how a data set should look, and it saved it inside this directory. Now, this file you can't actually open and look at because this is in sort of a computer binary format, so we can't just look at it. But this has saved that data to be usable. Now, in this documents directory, we have a R markdown file called myanalysis. So I'm going to open up myanalysis and look and see what it looks like. And what this looks like is a standard R Markdown file. But notice now I've got this library test package. Now this test package is the package that we're building, and what's going to happen is when I do this library command, it's going to load any data set that exists in that data directory. And so what I can do is I can just turn around and make a quick little graph using this maximum temperature data set, and it all works. So we don't have, inside this R Markdown file, I don't have to do any of the data cleaning. I don't have to redo anything because it's already been done for me. So that is very fabulous. Now the last thing that we need to look at here is the fact that in this R directory, there is now a maxtemperature.r file. And what this looks like is this is what's going to be the documentation that describes the data set that I've stored. So that if you do a question mark max temperature, something intelligent comes up. And that documentation of the data set lives inside this R directory. I want to first look at what we've got available and what we've done so far. So in this data raw directory, we have our raw data and our script that is going to produce a cleaned up version of it. That cleaned up version is going to live in this data directory, and that's going to be where the clean data lives. Second, we have in my R directory, I've got a file that documents the way that the format of this data set. And then once I run the documentation routine, there will be a file that lives in this man page. Man stands for manual. So this is where our documentation is going to live. So we're going to do two things, or two steps. We're going to take our raw data and convert it to a cleaned up version, and then we're going to take our documentation and convert it to an R readable version of that. So let's go back over to R, and I've got my data cleaning script already set up. And remember, it lives in this data raw directory. So what I'm going to do is I'm just going to go ahead and execute this file. So I've got everything highlighted, and I'm just going to run everything. Now, what this has done is it's going to take this data object that just got created. So we just created this max temperature, and it's going to save it to the data directory. So let's go over to the data directory, and there's my data directory, and there it is. This just got created. So we've now got a nice clean version of our maximum temperature data. The next thing that we're going to do is we're going to create some documentation. So remember, our documentation script lives in the R directory under this max temperature. Now, there's some formatting that goes into this, in particular this hashtag quote character means something very important. And we'll talk about this, the details of this very soon. But for now, let's just build the documentation. Now, the way that we go to build the documentation is we go over to this build tab. And this only exists if we're inside of a package environment. So if it doesn't exist, it's because we're not in a package. So the way that we're going to do this is we are going to go down to this more, and we are going to go down to this document command. And what that's going to do is that's going to build the package documentation. Now by default, this doesn't happen every time you build the package because documentation probably doesn't change very readily. So you have to specify that you're going to build the documentation. So let's go ahead and build that. And you can see that there's things going on, and it just wrote some documentation for this package. So let's go back over and look and see what just happened. So inside the man directory, we've got this maxtemperature.rd file, and this RD stands for R documentation file. And we could open this up and see what it looks like, but there's a bunch of things in here that are a little bit confusing, and this header up at the top says that it's generated using R oxygen 2, and I shouldn't edit this. But instead, if I want to edit the documentation, I should go to the R directory and edit the maxtemp.r file, and that's where the documentation, that the source documentation actually lives. So now we've created both the data set that we care about, the cleaned version of it, and the documentation. And we're finally ready to go ahead and do a standard build. And what this is going to do is it's going to reinstall the data, and it's going to recreate any functions that you define. So I'm going to go ahead and install this. And what this is going to do is this is going to build my package for me and restart my R session. And so now I can do something like I can install this package just as if it were any other package on my computer, just like if it were dplyr or ggplot2 or any other package. I can now say library, test package, and all the things that I should expect are there. Max temperature is now here. So if I say max temp, it'll go ahead and print out all of this data set that I have before. And likewise, the help command works. So if I say help max temperature, the documentation that I've written that lives right here is now in this nice format that is readable within R. So that is your very first package build. Next, we're going to talk about how to make the reference pages or the manual pages or the help pages. And the way this works is it works in two different ways depending on whether or not I'm documenting a data set or I'm documenting a function. Let's start with the data set documentation. So the way a documentation file is going to look like, everything is going to start with this little hashtag quote character. And this is the way, or this little hashtag quote is how the package roxygen recognize what should be documentation. So anytime you see a hashtag quote, that means this is documentation and it's going to be used by roxygen. All right, so for a data set, the way I want to document it is I need a couple of different things. I want to have a short title. So this is a very quick sort of one-line description of what the data set is. And then you can have a longer multi-paragraph section that really dives into the details of how the data was collected, where it came from, what considerations need to be made for it. And so this is really the expository section. And this can be as many paragraphs as you want. So this could be 5 or 6 paragraphs, however much documentation you need. Now, the next thing that you're going to want is sort of a much more formulaic version of what the data set contains. So this at format, that little ampersand is a formal thing that roxygen expects and says, all right, I know for data sets there's this thing called a format, and now we're going to go ahead and build this. So anytime you see an ampersand and then something, it's filling in a particular aspect of the help file. So the format should have some sort of description about this is a data frame, or this is a tibble, or this is whatever it is. And it's pretty common to say how many observations and how many columns you have. And then you've got this describe chunk right here, which its sole purpose is to describe each individual column. And so this is just going to be a list. So this is an itemized list, and you're going to have each of your columns as an individual item. Now notice I've got this item, then open curly bracket, close curly bracket, and inside should be the column name, and then a second set of open and close curly brackets, and inside here goes all of the description for that particular column. And so you'll have a nice description of column 1, including the units, and then we go on to column 2, then column 3, column 4, to however many columns you've got. And then the final bit of documentation is I need to attach this documentation that I've just built with some data set that is already created. And the way we do that is just outside of the comments, at the very bottom, we just, in quotes, we include the data set name. And that's how the roxygen wants the documentation for a data set. I've got an example of this in my test package. Now remember, this is inside the R folder in our package, and this is going to be where functions and data documentation live. And we've got this max temperature.r, and that is this file right here. And so I've got a short little description of this data set it's a time series of daily maximum temperatures in Flagstaff, Arizona. And then I've got a longer paragraph that describes the fact that this is coming from the Pulliam Airport weather station and was downloaded from NOAA on the date that I downloaded it. And then some other information, particularly that it spans the time between 1985 and 2015. These lines describe the format of the data set. And we've got a date column and a maximum temperature column. And then finally, I've got another little piece of optional information, and this is saying where the source of the data actually came from. Now that I've written my documentation that describes this max temperature data set, I'm going to go up here and make sure that this thing has been documented. And you can see that right now it is updating the documentation, and I haven't modified anything from this documentation yet. Next, I'm going to go and install my library. And because you do this so often while you're working on a package, there's a little button that does this. And there's also a little shortcut as well. So I'm going to install my library. And notice it's restarting my R session, and then it goes and loads my test package library. So at this point, if I do a help on max temperature, we'll end up down on this little area over here, seeing all of the information that I have. Now notice that I actually didn't quite do what I said that I should be doing, because I've said that this is a data frame, but I haven't given the number of columns. So if I want to update my documentation, I'm going to do it this way. And I'm going to just go ahead and modify this file and say with 2 columns. And then assume that it'll go into this. So the way that I'm going to update this documentation is I'm going to go back up to the build. I'm going to go to the document command. And so now it's updating the max temperature. And I'm going to reinstall my package. And now when I say help for max temperature, now inside the help command, we've got this extra 2 columns. So anytime you update the documentation, you're going to go into this little bit and rebuild the documentation. Documenting functions looks very similar to documenting data sets. We still have this hashtag quote character representing that this is documentation. We're going to have a short title as the very first line of the documentation. Then we're going to have some deeper details that are as many paragraphs of explanation as you want down here. But then we're going to have a few other things in here. You're going to have this at param. These at param items are going to describe the function inputs and what they're by default named, A and B here, and you should then describe what are the valid things that this parameter, this input value, what values can it take on? In this case, my A and B are just any real number. And then I've got a return object and then some examples. Now, this sort of makes sense when you start looking at the help files for some of the other functions on the system. So right now I'm looking up the sum function, and you can see that there's a short description. Then there is some arguments. So these are the parameters, right? Anything that you put in as a parameter goes right here. And then this details section, this is this larger set of details. So right here, this is going to turn into the details section. Now this value, this is the output of what the function lives or returns, and that is going to be given in this return object. So you can almost see that there's sort of a one-to-one correspondence between what my documentation looks like versus what these help files look like. And so you can look at it and go, okay, so there's some references, there's a C also, and then there's some examples usually at the bottom of my help pages. And so to look at this, you can see that we're going to have our short description, our details, the individual parameters, the return section, and then the examples section where you can call this function as you like. So then this is all the documentation that describes a function. Now the way that this function should be defined is it should be right at the bottom of this documentation. And so the documentation and the function live together in the exact same file in the R directory. And so when you're writing your function, you should also be considering the fact that you should be writing your documentation as well. This is a really good habit to get into because it allows you to think more clearly about, well, what should your function do? And as you're thinking about it, you're taking notes to yourself and making little examples, little toy examples that will end up being inside your example set. So keeping the documentation and the function together is actually really, really smart. We're now going to look at how to build a function in a manner that sort of replicates a professional workflow. And I'm going to encourage people, even if you're not a professional programmer, whenever you start writing a function, I think you would like to follow this paradigm because it'll actually help you out quite a bit in the future. So the steps to build a function are, first off, figure out what you want to do in terms of building a function. So at this point, I kind of figure out the inner workings a little bit and figure out what I want. So what I want to do today is I want to build a function that fills in a particular column. Now, we recently had a homework problem where we have this issue where maybe I've got a data set where I've got an A here, but then I've got a bunch of missing values, and then a B here, and then a bunch of missing values. And what I'd really like to do is anywhere I see a missing value, I'd like to go and grab the whatever is up above it. So for this row 3, I want to grab the A up here. So I really want to figure out how to write some code that does that. Now what I'm going to do is I'm going to just loop through each row here, and if I see a missing value, I'm going to pull from whatever is above it. And I'm going to do this in order. So I'm going to start with row 2 and say if there's something above it, grab it. Then row 3, if there's something above it, grab it. Now, what that's going to do is I'm going to fill in this A in the first step, and then when I go down to row 3, there'll already be an A up here, so I'll grab that. So let's write a quick little for loop that does that. So now what I'm going to do is I'm going to try to write this using just this df as it comes in. So eventually that df is going to turn into one of my parameter inputs. So I'm going to just write this code that looks like this. And I'm going to start with a for loop and say for row 2 to the number of rows of df. And now I'm going to say if I've got an NA, then go and grab it from above. So if, I want to say something like df, well, I need to name this. I need it to have I in. So if df sub I, okay, so row I, column, column. I need to have the column name. So right now this input thing is called name, but I'm not guaranteed that it's going to be name. It could be function, it could be last name, it could be anything. So I'm going to assume that for the function, we're going to have this input of the data frame, and we're also going to have the input of the column name that we want to fill. So I'm just going to say call name gets name, and I'm going to build all of my function off of this. So these two are currently the inputs that I've got. So I'm going to say call name. So if there's something missing, so I want if is.na, then df I, again column name, gets df I minus 1 call name. Cool. Close that if, and then close the for loop. So this seems reasonable. So I'm going to execute these guys. And now let's see what happens. I think this should work. Yeah, it did. Cool. So that filled in this chunk. So now essentially I've got the guts of my function, and I also know the two parameters that I need to have to come into this function. It needs to be called, I need a data frame, and I need to know the column that I want to fill. So that's sort of the first chunk of this. Now, in the process of figuring out the guts of this code, I've also defined the input and the output. So the input is a data frame and the particular column that I want. Now I want to have the output also be a data frame as well. So this pretty much is defined, and now all we have to do is wrap this up as a function. So let's go ahead and do that. So I'm going to say, I'm going to call this function fill underscore column. And this is going to be a function, and the input is a data frame and a call name to be filled. And I'm going to do a little indenting. And what I'm going to return is this data frame, and we've got our function defined. At this point, it's tempting to just highlight this command or this function definition and run this code and create a new function. But the problem with doing that is then you've created a function just for this R session. Instead, what we need to do is we need to associate this function with this package, and we haven't done that yet. So the way we're going to do this is by building the documentation that will both document the function and associate this function with the namespace of my package. So all I've done so far is I just took some of my code that I was using as I was building this and turned it into my documentation code. So I've just added a little quick description that this function is going to fill in missing values. My details section is pretty sparse right now. But I've included the two parameters that I think are necessary, and I've added the return type as well. And I set up this little examples thing to work so that I've got this, I define my data set, and then I call my function that is going to be fill column. Now, the last thing is this export command. And what that export command does is this is going to be the part that associates the function that I'm about to define down here with this documentation, and it says that the function that I'm about to define is going to be available for users to use. So you can imagine a package where there are a bunch of functions that are only sort of detail level things that need to be used by the package, but a user shouldn't know about it because there's no safety things, there's no documentation. It's, it's some sort of function that is just meant for the developer. This export says this is a function that the user of the package should be able to use. So that's what that is. Now that we've got the documentation all built up and the function sort of in a way that I think I'm happy about it, we need to actually attach this function to the namespace of the package. And the way that we're going to do this is not this install and restart. That actually doesn't work just yet. Instead, what we're going to do is we're going to go over to this document function. Now, the reason why we have to do this is at this point, the package doesn't know that this fill column function even exists. And this first step of the document is to build the namespace of the package. And the whole goal of that is to associate a particular functions to that package so that when we actually go ahead and install the package, we know that that thing is there. So this documentation happens, see right there where it's writing its namespace, that's actually what actually we needed to have happen. So now we've got this fill column and it's associated with the package. And now we can go ahead and install this package and we should be good. So it's restarting, it's going to load my package, and now I can go ahead and run this command for this df, and I can go ahead and run this command for fill column, and now that works. And so now we've got this fill column, there's this function that works, and we also have the help files for this. So I've got the help files for fill column, and we've got all of this down here. So now we have a function that is associated with the package, and when I load this package, I've got that function and it works. And it'll run and it'll take whatever it wants, as well as the documentation. So this is really cool. Most people are tempted to stop right at this point, but we want to push this a little bit farther. And the reason why we want to push this a little bit farther is that the next step of this issue is making sure the function works on simple cases. Because while my function is very simple, what happens if I've messed up the name or something else? And I want to make some test cases and I want to save them, because right now the question becomes, what happens if I send in a function that has only one value that's not NA? What happens if I send in a whole of a vector or a data set where the entire column is NA? What happens? So I want to make some test cases and I want to be able to rerun them whenever I want. And so this is sort of the professional aspect of things, is we want to build our test cases and we want to build a setup where it's easy to run those test cases whenever you want. To do that, we're going to use a package called testthat, which is going to be our quality assurance, our QA testing environment. The first thing that I'm going to do to set up our package to allow the testing is we're going to build the test package stuff. So the way we're going to do this is we're going to use Hadley's use this package, and the thing that I want to use is to use this to use underscore test that. Now, this command is going to do a couple of things for us. So it tells us that it's setting the active project to this. It's going to create a document. It's going to create a folder called tests, test that, and it's going to write a testthat.r function that'll actually be a script that'll run all of the testing commands that we're about to build. So you can see that now there is a new folder called tests. There's a folder called test that. Now this folder is where we're going to put all of our tests that we're about to build. This R command right here is, all it does is it is going to call this test check thing, which is going to go in and look for any files in this test that directory and run those files. So our next step is to build these files. So I've just created a R script that is called test underscore fill column. And this script lives in the test that directory. So inside my main package, I've got a directory called tests. Inside that, we have a test that directory that got built when I did the use this thing. And now I've just created this script called test underscore fill column. And this is where all of the tests that we're going to use that will test this fill column are going to live. All right, so the this context thing is sort of shows up in this fill column bit. So if inside this script I want to modify this so that there's some sort of structure there, we've got this extra sort of header bit. All right, so I've got a test that command that is going to just test the simple cases. So I'm going to have this little simple case thing, and I'm going to have some commands that are going to, that I think should be an appropriate test. So what I'm going to do is I'm going to first define this A and B thing. So that's what these first two commands are going to do, is define a data set A and B. And A is going to be my starting data set, and notice I've got some NA values in columns or rows 2 and 3 and 5 and 6. And what B is going to be what I want it to turn out to be at the end of this. So B is going to be, well, I want this two and these two rows to be filled in. So what I'm going to do is I'm going to call fill column using my A data set, and that should be identical to the B. So I've set up B as what I want, and A is sort of the starting point. Now this expect equals, this is a test that command that basically says, all right, well, I'm going to expect two things and they better actually match up. And if they do, expect equals just, it doesn't say anything. It says, oh, it looked at this and said, all right, this versus this, they're equal, and that's what I expect. So it doesn't say anything. Now, if I modify this, let's go and change this to C. Now, when I run this, A and this input and this input, they're going to be different. So now expect equal throws an error and it says, oh, look, this fill column A is not equal to B. And it sort of gives a little bit of information about what the mismatch is. So this gives me a way of saying, oh, these two things don't match. So in this case, I want to go back to the original bit. So now those things are going to be equal. Expect equal doesn't throw a fit. I'm going to make a C and a D. Now, the difference between what I did before and this is now I've got another column called value, and I've got an NA in this case. Now, I don't want to touch that. I think fill column should only interact with the column that is specified. So I'm going to make this my dumb column, and we want to fill this in. And in this case, we're basically testing that expect equal only interacts with the thing that it's supposed to interact with. And correctly, it does. Now, as I think about my function, maybe there are things that should happen. So if I input a data set where I try to fill off of this column, but that first element is NA, then maybe I should have an error show up. Maybe it should say, oh, you've got a warning or an error or something like that. Maybe it should complain somehow. So right now, when I create this, right now I've got A, and everything is NA. So this first, what's going to happen is when I look at row 2, it's going to grab the NA from row 1 and replace the row 2 NA with whatever is there, but that's an NA. So nothing is going to happen for the first 3 rows. But when I get down to row 5, it's going to appropriately grab the B and fill in the B's. So when I run this fill column, the B's get filled in, but the A's don't. So maybe I think that that's a bad idea, and maybe I want my function to throw an error at that point. Now, at this point, an error wasn't thrown, and So now what I want to do is I want to go back and talk about how do I do this. Now, I've got this nice little test environment, and over here you can kind of see that I've been playing around with this. And the way that you can do this is you can go down and you can run this test package, and what'll happen is this testing script that you've developed will actually get executed. And so now we're going to load this test package, and it fills things in, and it goes, oh look, in my raises error sections, so that's this raises error sections that I've got here, it found one of the tests that I did found a problem. And it's the fact that we're expecting it to throw an error when in fact it does not. So let's go ahead and modify this function to do that. So let's throw in an initial check here. So let's go if is.na df row 1 and then call name. So if your very first row in the column that you want to fill is an NA, then we're going to throw an error. And the way we do that is we're going to call this command that is called stop, and you can give it a description of what the error was. So first row has an NA value. Cool. So now we've got our function built up, and now what we can do is we can reinstall my function or reinstall my package. And now I'm going to go over to this testing, and I'm going to call this and see what happens. Ah, excellent. And now we've got an error that comes up, and it says the first row has an NA value. Excellent. And so now when I do this expect error actually is fine with this because my function did throw an error. And so now I can go and I can retest my package, and it reloads the package, and all 3 of the tests that I have defined so far have passed. No warnings, no skip tests, and currently, based off of all the testing that I have developed for my function, everything seems to be working just fine. So in a professional software development environment, these testing environments are really incredibly important, because as programmers are modifying the code base and changing things and trying to add new functionality, the absolute worst thing that they can do is break old functionality. And so by developing a testing environment that every time you create a new build, you go ahead and you run the tests and make sure that you haven't broken old functionality, you build a much stronger and much more robust software package. And this is a part of being a professional software development environment is, can you run testing situations, and do you run it consistently? And that's part of your standard workflow. And so the test that package gives you the ability to do that within your own software packages. The last thing that we're going to modify is the description file. Now, when you first build a package, the description file shows up and it's just filled in with sort of a base template information. And it asks you to sort of fill in your title and a description, like a 1-paragraph description, along with who actually authored the package. Now, the most important thing in here is probably what's going to be referred to as the depends and imports and suggests codes. Now, what these are packages that have to also be installed in order to use your package. Now, the depends package, anything that is in this depends row, is going to also be loaded every time the user loads your package. And so this magrittr package, the magrittr package actually defines the pipe operator, and I use that all the time in the code that I utilize. Now, imports is a little bit different than depends. Now, both depends and imports requires that the user has downloaded the packages that are in here. So by having depends and imports, then in order to use my package tidyr, ggplot2, dplyr, magritter, all of these packages have to also be installed. But there's a difference between imports and depends. Depends causes magritter to actually be loaded, whereas imports just means that it exists on your system, and in order to use it, you have to use the package name function name syntax within your package. So if I've got a function that maybe I need some tidyverse stuff, then every time I do something, then I'll do something like dplyr : select, dplyr : mutate, dplyr : arrange, etc. Now, the reason why I would choose to do this is so that there isn't a collision with the namespace stuff. So if you recall, the mass package and dplyr both have a select function. And depending on the order that you load these libraries, select might be coming from the mass function or mass package, or it might be coming from the dplyr package. And this is really, really annoying. And so for packages that are going to be widely distributed, it's highly recommended that you do as few depends packages as possible and just rely on imports instead. Now, for a data analysis package, which honestly most people are in this course are going to be using, I usually leave the depends and imports and suggests just completely blank. And what I'll do is I'll load whatever packages that I need for my data analysis in my documents directory in those files. So if we go into my directory here, my analysis package, inside this analysis package, we will have my library for ggplot2. So in general, for a data analysis package, don't worry about any depends, don't worry about any includes, just within your R Markdown files where the analysis happens, include the libraries that you need.